speaking from a handout today. That handout is available for download on my website. The website is streaminglearningcenter.com. If you go to that site, scroll down to Learning and click the Download Per Title Encoding handout link here. Where'd it go? Here, you'll be taken to this page where you can download the handout. There are lots of numbers and charts and graphs and things, so probably would be good if you got it rather than trying to snap a picture of every slide that comes up here. So again, it's streaminglearningcenter.com, and scroll down to the third line of the content area, which should be Learning, and then here's the article with the handout. So here's our agenda for the next 45 minutes. We'll talk about what per title encoding is, why it's important. We'll spend a lot of time on our contestants. We'll look at our tests and, of course, the results. Per title encoding is customizing your encoding for each file. So we started out, 10 years ago, Apple produced TN2224, the recommendations for an encoding ladder, and a lot of people had one encoding ladder for all video. Of course, everybody who knows video and who has encoded video before knows that no single ladder works well for every kind of video. Animations encode differently than talking heads. But nobody really had a technology for that until late 2015. Netflix came out with a blog post that talked about per title encoding, and it really just totally changed the paradigm about how compressionists should approach encoding their video. And soon thereafter, YouTube revealed their schema, which is a neural network-based schema, pretty intelligent, probably beyond the capabilities of most companies, but reinforcing the fact that per title encoding is the clear way of the future. And we saw the first encoder implementation last year, I want to say early 2016, a company called Capel Systems. They introduced the Cambria encoder that had a version of per title encoding that we're going to be looking at today. And since then, a bunch of companies have come out with it. Brightcove has a system. Fastech, who is here at the show, has a system. JW Player, the OVP, uses CAP CRF. That's a technology we're going to be looking at. So there's a lot of ways to get there. And what's kind of fun about this particular presentation and this particular analysis is that we're at the very early days of per title encoding. So it's kind of a fun look. It's a greenfield look. There's not a lot of work on how to analyze these tools. So I kind of tried to have fun with it. And this is all suggestive stuff. I think we're a little bit, all the systems that we're going to be looking at are very highly customizable. So I approached it in a pretty regimented way, but it's hard to say what's right, what's wrong. And this is more like, okay, this is the direction we're going in. Here's the things we liked. Here's the things we didn't like, rather than this one's good and this one's bad. And I think it's important to keep that in mind because we are very early days. And this is just my first take at this analysis, or second take, actually. I had a webinar on this a couple months ago. But it's still, again, very early days of capped CRF. Now, why is optimizing the bitrate important? You guys, I think, know all this. From the consumer side, you want to reduce the bandwidth as much as possible, as well as improve the quality of experience. It's not all about decreasing the bitrate on easy-to-encode files. It's also about increasing the bitrate on files that are harder to compress so you get better quality of experience to your viewers. And then on the producer side, you get lower bandwidth costs, lower storage costs, lower encoding costs, because you may be able to cut out some encodes using these technologies. You get better reach to consumers on the edge of networks, higher quality video to people watching on cellular connections. You're going to be more competitive because of consumer side benefits. Consumers will like your technology better if they can use it and save disk space for downloads or bandwidth for streaming. And I think this is going to be, if you're selling an encoding product or an encoding platform, I think per title is going to be table stakes within the next 12 months, meaning if you don't have it, you're not in the game. So I think this is just the clear wave of the future. Interesting. Netflix is already moving on from per title to per scene encoding. So they're taking it one level further. So I think this is just the first step, but I think it's a pretty critical step because, as I started out by saying, everybody knows that all files do not encode equally. So you need to incorporate that into your encoding schema and pass the benefits along to your consumers and customers. So let's briefly take a look at the types of adjustments that are available in per-title encoding techniques. And this is Netflix and YouTube's implementations. Netflix's implementation is, I call it a brute force implementation. Basically, they just encode each file hundreds of different ways, measure the VMAF quality using the VMAF quality metric that they use, and figure out the best combination of resolutions and data rates to serve their customers. Very brute force. YouTube can't do that. They're getting 300 hours a minute being uploaded, so they use a neural network to basically guess at a way to get that done. But on the left, you see the features. So Netflix can adjust the data rate of each clip, and that's kind of what everyone does. But they can also change the number of files in the ladder. So we'll be looking at 4 technologies today we'll be looking at. 2 can change the number of rungs in the ladder, and 2 can't. And I think that you'll see why that's so beneficial when we get there. 2 of them can also adjust the resolution of the clips in the ladder. Why would you want to do that? Because if you're working with an animated clip or a screen can clip, you'll get much better results at 1600 by 900 than you would at 800 by 400. The higher the resolution for animated clips or synthetic clips, the better the output. Some technologies can do that, some can't. In terms of customizability, this is the ability to, for example, Brightco's system is very highly customizable. You can select the minimum bit rate, the maximum bit rate. You can say, OK, files below this resolution need to be encoded with the baseline profile. Files above this can be main or high. So a lot of stuff that you really care about. It's not just about getting the lowest possible bit rate. It's all the other things we have to do with an encoding ladder. We've got to maintain compatibility with our target platforms. We've got to maintain a very efficient switching mechanism within the encoding ladder itself. So it's not just reducing the data rate. It's also, again, presenting a deliverable adaptive bitrate experience. Bitrate control is going to be a big issue for CAP CRF. So can these technologies give you lower bit rates, but also bitrate control, like 110% constrained VBR or CBR if that's what you prefer? Yes or no? Some can, some can't. And then is there a post-encode quality check? Do you have the ability to say, OK, if this file is under X, pick your quality metric, I want to re-encode at a higher bit rate. So these are the kind of things the kind of features that we see in the very expensive, very highly developed technologies produced by Netflix and YouTube, and we wanted to see what was available in the technologies that we're looking at. So again, we had 4 systems that we analyzed. CAP CRF is used by at least one OVP, JW Player, and it's available for FFmpeg. X.265 can do CAP DRF, VP9 can do CAP BRF. So it's a pretty accessible technology, and it actually works pretty well, but there are some considerations and some concerns. Capella Systems, we talked about, they have a feature called Source Adaptive Bitrate Ladder. It's a standard feature of their Cambria FTC encoder. I reviewed this last year, and you can read the review at the URL shown. Brightcove debuted context-aware encoding a few months ago, 6 or 7 months ago. It's going to be a standard feature for end-to-end Brightcove OVP offering. A lot of stuff isn't set in stone yet. Will Zencoder offer it? What the price premium, if any, will be. So that's not, or it wasn't available the last time I asked them. And then FastTech IO, actually it's not a quick preview, it's a pretty full review at this point. And they're here at the show. So they have a feature called Intelligent Content Adaptive Video Compression, and they're at the show if you want to explore it further. Everybody ended up doing pretty well in my test, but they did well as well. So how did we test? And this was, like I said, it's greenfield, right? So you couldn't look and see how other people tested before. You kind of had to make it up as you went along. So what I decided to do is I just picked 15 test clips that I had laying around, 2-minute test clips. And they're all 1080p, and I didn't look at 4K at this go-round. And then I said, OK, everybody's starting with a fixed bit rate ladder. right? So really what we're trying to understand here is what is the advantage of per title over a fixed bitrate ladder. So I had to pick a fixed bitrate ladder, and this is one I've worked with a number of different customers. There's nothing magical about it, but that's basically my starting point. So what I did was, with all the technologies, I encoded to this fixed bitrate ladder, and that was my baseline, that was my starting point. And then I submitted those 15 files into their per title encoding technology and got back my results. And then I compared the baseline, the fixed bitrate ladder, to the per title. And it sounds pretty simple, but you see there were some interesting things we had to deal with. Now, the data rate, I basically told all the technologies you can vary the data rate by as much as 150% on the high side, take it as low as you want. And then beyond that, I didn't do a lot to try and normalize the compression between the various different technologies, right? I didn't say you have to do it this way. I said you have to do it consistently between your baseline and your per title. So Brightcove's encodes are not comparable to Cambria's encodes or FastTech encodes. So don't look at the VMAF values between the different technologies and draw conclusions there. Just look at the baseline encodes to the per title within each technology. So I didn't normalize between the encoders. I just normalized between the baseline and the per title. Is that clear? So draw no conclusion. I didn't even look at the differences. I suspect there aren't that any, but don't draw any conclusions about the encoding technologies beyond what I'm specifying. So how did I interpret the results? I interpreted the results using the VMAF metric, and VMAF is a quality metric that was produced by Netflix, and it's used in their per title encoding engine. So I started off, when I did this like 3 or 4 months ago, I used PSNR and I used VMAF as well. And then one of the contestants said, well, that's confusing. Why are you looking at both? And then I said, OK, fine, I'll just use VMAF. And VMAF is it's a metric. It's now available in FFmpeg. I understand. I don't compile FFmpeg. I use it a lot, but I don't know enough about FFmpeg to compile it. But I got to it via a cloud encoding platform who's here at the show called Hybric. So what I did was, I encoded my files, I uploaded it into Hybric, I ran the VMAF score, and then I put them into a table and I started manipulating those numbers. You can also get VMAF scores in the Moscow University Video Quality Metric tool. So it's coming out in their newest 10.0 release, or now it's beta 10.2. So VMAF is becoming very accessible, and that's what you want in a metric, because you want a lot of people using it, and that's how it gets viability. Now the scores for VMAF range from we'll see scores as low as 5 or 6 all the way up to 100 or even higher than 100. There's no absolute value. You can't assign a subjective rating depending on the value. If you've got a 640 by 360 clip and the VMAF rating is 42, you don't know if that's good looking or if it's ugly. You just know that if it's 42 here and 41 here, this clip has higher quality. What you do know with VMAF, which I think is significant, is that plus or minus 6 points is a just noticeable difference, which means a significant percentage of people will notice the difference if the VMAF score goes beyond 6. And that's one of the things I really like about the technology, because it adds a lot of perspective to the numbers that you look at. So here's all my caveats. and what I tried to do, I tried to come up with a formula that would allow me to rank them. And I came up with kind of a baseball formula. And it looks at wins and losses. It looks at home runs. It looks at saves. And we're going to kind of walk through that over the next 20 to 30 minutes for all the contestants. Now, there are some absolute gradings. So this is, here's, we talked about my starting point and my ending point. And, on the left is the baseline per title encode for, some file by some technology. On the right is the output. So we see on the output a couple of things. Number one, there are fewer rungs on the output than there were on the input. So this is a technology that not only can change the data rate, it can also reduce the number of rungs in the encoding ladder. So what we see here is the absolute savings for storage associated with this technology. So with the fixed bitrate ladder, here we produced 12 megabit per second of files for this particular file, and here we produce 6. So we have 52, 57 storage savings for this file. So we'll look at the absolute storage savings produced by each technology. And then the bigger question, so this is pretty absolute, right? We understand this. The bigger question is, how do you grade the experience delivered by per title as compared to the absolute file savings of per title, especially when you're looking at technologies that put out different numbers of rungs. You can't just compare rung by rung because some technologies don't have all the rungs. Besides that, it's not particularly relevant, right? We don't care how it looks rung by rung. We care about what a person viewing at a particular bandwidth would experience with a fixed ladder as compared to a per title ladder. Does that make sense? So what I did with the per title ladders is I basically said, okay, here's the target bit rate we use for the per title encodes. Which file fits under that bit rate limitation? Which video file would a person constricted to that bit rate actually view with the per title encode? Does that make sense? Please tell me it makes sense. The next 30 minutes kind of depend on that, but that's the approach I took. And then what I did to kind of compute the overall benefit was, here's the VMAF rating from the baseline encode. Here's the VMAF rating from the per title encode. What's the difference? What's the data rate savings? And these numbers here kind of represent 98% of what I'm looking at when I'm comparing the technologies and when I'm judging their effectiveness. So either you buy into the rating or you don't, but this is the basis that I used. So in this particular case, we see a technology, and this is probably, this is the Epiphan clip. So this is a clip that was part screen cam. Yes?
Can you explain at least the second table, the data rate seems to be unchanging as well as the resolutions multiple times.
Say it again?
On the second table,
yes.
The data rate seems to be 841, 841, 841 for the 1080p 5 times.
Okay.
Is that coming from different vendors?
No. Somebody explain why. Make me feel good that I've actually communicated that. Tom, you got it?
Well,
he never gets what I.
Correctly, that was just one stream that you're plugging in place of those different streams for the baseline.
That's right. So here what I did is I said, okay, what's the highest quality stream that could fit under this bit rate here, right? So for this particular clip, which is the Epiphan clip, again, mixed screen cam and talking head. So it's a pretty efficient clip to encode. The 1080p clip came out with this technology at 841. So I was able to stream the 1080p clip all the way down to 900 kilobits per second. So rather than streaming a 360 by or 640 by 360 clip, I could stream the 1080p clip at the same bit rate. And the savings, we went from 70.99 VMAF to 91, which is like 3 JNDs. So that's what you're going to see a lot.
Yeah, are you going to show bits per pixel? Because you're arguing that 1085 I'm sorry. So
I'm not going to let competitors talk during this.
okay.
Okay. So this is this is FastText.io, and you want to talk about it later, we'll talk about it later, but we don't have a lot of time to go through the materials, and I'm not sure it's appropriate anyway. Unless you see something, if you see an error, talk to me about it later. It's been a tough day. Anyway, this is the analysis that I put together to try and gauge the efficiency and the how well each technology performed. Now here's where we get to the baseball part. So how did I judge a win and a loss? A win was any time we reduced the bit rate here and didn't reduce VMAF score by more than 2.99. So basically, if the average was under half of a just noticeable difference and you decrease the data rate, that was a win. From my perspective, that's a win. A home run is any time you increase the overall experiential VMAF score. So here we see at this technology, because we were able to use the 1080p clip with a higher VMAF score all the way down to the 640 by 360 clip, we improved the quality of experience of this viewer, and that's a home run.
Increase the VMAP without increasing the data rate.
Correct.
It's a home run.
Yeah, most of these clips were reduced. But yeah, I'm not sure if I took that into account or not. But probably 95% of the clips were reduced as compared to increased. And then a home run was this. A triple basically said you were a win, meaning this number was no lower than minus 2.99. And a single, the data rate benefit was 0 to 10%. A double was 10 to 20%. And a triple was anything higher than that. Does that make sense? So I mean, and then, and then you have to have errors, right? So an error is any time you, on a particular rung to a ladder, you produced higher than the target. Why is this an error? Because in this case, this cellular customer may not be able to watch the clip. Okay, now I didn't count this as a loss because most of the technologies, if it's configured correctly, should be able to guarantee that this doesn't happen. And as I said, this was kind of an evolving thing, so not everybody knew how I was going to score this when they produced the files. So I counted it as an error, something to watch for, as opposed to a loss. And then the other error was if something came back or if the files came back and there was a jump greater than a factor of 2. So what we're looking at here is an encoding ladder. And what you want to do in your encoding ladder is you want to make sure the data rates jump pretty gracefully. And that way there's a good interval and you're not going to strand any viewers down here by having a gap that's too high. You also want, files that are too closely gapped together because then you can switch data rates and get no real benefit. So and the error that we saw, and we'll see this in one instance with CAP-CRF, but the error was anytime there was a gap greater than 2, except at the lowest gap. So this wouldn't count as an error, but you'll see an example of it with CAP-CRF. And then a save is anytime you decrease the numbers of rungs in the ladder. So why is it a save? Because you're encoding fewer rungs. That means less encoding cost. Obviously, it translates to lower storage costs as well. In this case, we'd have a save. We'd have 2 saves because we cut 2 encoding ladders. If you go from 2 pass to 1 pass, you also has a save as well, and that's where CAP-CRF did really well. Okay, so that's how I scored. Now we're going to start looking at the individual contestants in the that I considered in my evaluation. So CAP-CRF was first. Again, that's available as an encoding mode in X264, X265, VP8, and VP9. And basically what you do with CAP-CRF is you say, OK, I want you to encode to this quality level. And it's focused on quality, not data rate. But I don't want you to go beyond this cap. And that's how it works. I mean, it's a pretty simple technique. And then I also set the buffer size as 1 second of video because that limits variability to a degree as well. But basically, it's like you set a quality level and you cap it. So what do we like about, or how does CAP-CRF fit into our evaluation schema? So it's a CRF encode, pretty well established in the encoding world. Everybody knows what that does. It does adjust the data rate. It does not change the number of files in the encoding ladder. Okay, so if you start with 7, you're going to end up with 7. It doesn't adjust resolution. It doesn't have a lot of customizability. And the biggest issue, and you'll see why in a second, I have with CAP-CRF is that it doesn't allow you to control the bit rate. So you can have extreme amounts of variability in the file. That can translate to deliverability issues that translate to lower quality of experience.
Can you set a minimum bitrate for the CAP-CRF?
I don't know the answer to that. Anybody know? Yes? Okay. Okay, and here's the one of the slides, or one of the files that I tested was a file called test, and it has 30 seconds of talking head followed by 30 seconds of ballet. So, you know, very low motion, very high motion. In a file like that, you get very, very disparate regions in the file, which in my experience can interrupt, you know, you can get stoppages, you can get quality swings within the delivered file. So that's my big concern. Some people buy into that, some people don't. But very limited data rate, or actually no data rate control, because it's totally, you know, it's only limited at the top. And this is going to give CAP-CRF an advantage when it comes to overall VMAF savings, particularly as compared to FastTech, which did a really good job controlling the data rate of their files at 110% constrained VBR. So if you have two files, one is encoded like that, one is encoded at 110% constrained VBR, that file is going to have a higher VMAF rating because, you know, it's got much greater data rate swings to account for the higher motion. So, you know, another reason you shouldn't compare the quality of the different technologies. And as a counterpoint, JW Player uses this, and I'm sure they wouldn't use it if it caused problems. So it's a consideration for me. So how did CAP-CRF do? Well, it was 15-0, the only technology to complete all 15 files. It saved 39, and you'll see how these all sum out when I present all 4. But it saved about $40,000 bits of data. The streaming saved was around 208%. The net impact on VMAP was a positive 65.47. That was pretty impressive. If you're interested in saving encoding costs, CAP-CRF is a one-pass system. So it's a very efficient from, you know, basically every other technology had to encode each file twice. Some technologies like Capella Systems and Brightcove and FastTech, they analyze the file beforehand. So it's not only 2x for the 2-pass, it's 3x, or some factor of 3x. So very efficient system, a lot of saves, and a lot of home runs. I mean, it did a really, you know, pretty impressive job. It also had some significant errors. And here we see an example of a jump from 2.282 to 5800 at the top level. So what does that mean? If you're a viewer and your effective bandwidth is around, you know, even 5 megabits per second, you're still going to be stuck at the 720p stream. And that again translates to lower quality of experience. What can you do to save that? You know, maybe you can try encoding your top quality clip at a lower CRF value, you know, to make sure it doesn't go as high as some of the others. But that was my big concern for CAP-CRF. And then the highlights and bloopers, because you can't talk baseball without highlights and bloopers. You know, it did a very good job on the screen cam clip. And this is, you know, we saw an example of this when you asked your question. You know, we were able to use the 1080p clip, you know, very, very far down the encoding ladder because it was encoded so efficiently. So that contributed to an overall 17.88 plus on the VMAF score, while averaging a data rate reduction of around 15%. The negative, the blooper for me, again, is the quality of experience issues for CAP-CRF data rate control. Capella Systems, they have source adaptive bitrate ladder. It's a standard feature of their Cambria FTC encoder. As far as I know, this is the only standard encoder you can buy that comes with any kind of per title encoding beyond, you know, CAP-CRF, which most of them should be able to do. And what Capella does is they run a quick CRF encode of the entire file. Then they come up with the data rate from that encode, and then all this stuff you set up. Basically, you say, OK, if the data rate comes back and it's, and let me, first you set your standard encoding ladder, right? And that was the encoding ladder we saw way back at the start, the seven ladder. And then it says, OK, if the file comes back and it looks very complex, raise the data rate of every rung on that ladder by 1.5%. And at the other side, if it comes down very simple, you can reduce it by as low as you want. Now, this is all entirely configurable, right? You could ad infinitum. And actually, when I ran the final set of tests, I think we brought this all the way down to 800 kilobits per second, and we reduced the encoding ladder, by 75%. So it's a very flexible system from that perspective. And it's all implemented as a JSON script. I am not a coder, but they were able to, I said, hey, this is what I want to try. Can you do it? And they sent it to me. And you'll see, they're a very responsive company. And if you can't figure out how to do it, I'm sure they will be able to help you with their customer service. What can you configure? You can configure the duration measured by the CRF encode. So they encode the entire file using CRF. But what they're looking for is the toughest, by default, toughest 30 seconds of video. So the number you saw, the 5,000 or the 7,000, that's the toughest 30 seconds. And then you can make that as short as long as you want. If you make it 2 minutes, you're going to have a more aggressive encode because it'll average out the value for the hardest 2-minute segment. If you make it 10 seconds, it's a very conservative encode, but you're letting the most complex 10 seconds of your video control the encoding for the entire video file. So you set that. You can also increase resolution for simple videos, decrease the number of rungs for lower bit rates. So if you have, if you end up with a very easy to compress file, and the maximum bit rate is 800 kilobits per second, you don't have to produce 7 files. You can say, OK, any bit rate under 200 kilobits per second, just eliminate. And here's what we see from their output. We see for, I think this is the tutorial file. So this is or screen cam file. And what we're seeing is not only did they cut bit rates, so they cut 3 ladder layers because they had a layer at 180 kilobits per second. They also increased the resolution of the second encode from 720p to 900p. And that's really one of the keys to getting very, very high VMAF scores, because if you compare the 1280 720 on the left, you've got 88.66. The 1600 by 900 is about 2.5 points above that. And if you can push that down into lower rungs, you're going to get dramatic VMAF savings and dramatic quality of experience savings. And essentially, Cambria is CRF with better data rate control, because they're using the same mechanism. And what we saw is we had better storage saved, not as much streaming saved, about the same impact on VMAF. We saved some encoding ladder rungs, but nowhere near as much as eliminating the entire first pass for cap CRF, and then not as many home runs. Because again, this is a more data rate constrained technology. It's not going to produce the home runs that we saw with cap CRF. The highlights, this is the talking head video. Again, we were able to push the 1080p all the way down as low as the 480p clip, which really, and push other rungs down. So we were able to produce a net positive of 11 VMAF with saving about 17% data rate on this clip. And then Brightcove context-aware encoding. Some of this could be, again, how they're going to offer the service is a little bit in flux. Basically, it's, let me just show you what you can do. You can choose all these variations. You can set the minimum renditions, maximum, max data rate, keyframe rate, all that stuff. And this is what the JSON looked like for the test files for me. So basically, as you see, they were able to, and all of the vendors, I mean, I did Capel and Cap CRF, Brightcove did their own encodes with my input, and Fast did their encodes with my input as well. But this was the JSON that was used, and I actually submitted these files for the encode with the Brightcove Zencoder system. So you can see the types of things you can control, and a lot of this is pretty important, right? Because you want to be able to set the minimum bit rate, because you want to be able to preserve that for your cellular customers. So this is what it looked like. And architecturally, the core schema is probe encodes. They do some sample encodes of the source. They can adjust the data rate, can adjust the files in the ladder, can adjust the resolution. There's extensive customizability. You do have bitrate control, so you can say, yeah, I want 110% constrained VBR or whatever technology or schema you want, and you can do a post-encode quality check. And here's how Brightcove did. They were 13-in-1. They saved more storage than the other two technologies. They saved more streaming than the other two technologies. They had a higher net impact on VMAF. And that's primarily because they hit a lot of home runs, like Cap CRF. And the thing that they did that Cap CRF didn't do is they cut encoding runs. So Cap CRF, you start with 7, you end up with 7. With the Brightcove system, very aggressive to cutting encoding runs, which saves storage and ends up saving VMAF scores as well. The highlights, this is the El Ultimo clip. This is an animation. Again, they were able to push 1080p down one rung and push the 900p, which is a stream they created because it was a low motion animated clip. And they produced a net VMAF benefit of around 11 while cutting the data rate by close to 25%. So just imagine that. They cut the data rate by 25% and improved the quality experience on average by greater than 1.5 just noticeable differences. So it's pretty striking. What did they mess up? They basically, on this one clip, the one loss they had, they dropped a rung in the encoding ladder. And essentially what that did is it forced a comparison between a 576 by 324 clip with a VMAF score of 66.21 against the 480p clip with a VMAF of 82.45. So they never, this is a hard to encode clip, and they reduced the number of rungs, which is counterintuitive, and it cost them in the loss column. And the last technology is FastTech IO. Again, they are here at the show. It's a script-based technology. You set a VMAF target. It figures out the data rate necessary to achieve that target at 1080p. Then it uses that calculation to compute the encoding parameters for all rungs below that on the encoding ladder. It is a 7-rung in, 7-rung out system currently. It does not change the resolution currently. And one of the things I observed is it's really got excellent bitrate control. I skipped a slide. Or they were out of order, excuse me for that. So this is FastTech scoring. How did FastTech do? FastTech had 2 losses, you'll see why in a second, but we're 12-2. And they were slightly lower than the other technologies in some key areas. Again, you'll see why in a second. And they had 9 errors, and the errors were basically they just didn't meet the data rate at the low end of the target range. Part of that was because I didn't tell them that they had to meet the data rate at the low range, because that was, again, a late item that went into the scoring. So I wouldn't beat them up too much about that. The thing that I noticed was more than any other technology, on a rung-by-rung basis, they tended to be a bit more aggressive on the encoding side. So we see on the 720p rung, we lost greater than 6 VMAF points for both 720p and 540p. So they reduced the data rate too much for that rung, causing in excess of a just noticeable difference. And they did that twice. And that's just too aggressive. And then here's kind of how things won out. Overall, I don't, again, as I started off saying, there's no winners and losers. I think, they're all very good technologies, but Brightcove did very, very well in some of the big numbers. CAP-CRF is an attractive technology. Other than the bitrate control, Capella Systems, I think, does a very, very good job and is the only commercially available encoder in this class. And Fastech, I think, did a very good job considering they came in late, and they only had one pass at this. I mean, I work with Capella and with Brightcove for the webinar I put on. So we were familiar with the system. We tuned it once or twice before we came up with this final encode. Fastech, it was a one-shot only. So I think they did very well given that reality. And then I think what you're seeing up here, these numbers are quite compelling. I mean, you're seeing significant storage savings, and you're seeing significant streaming savings, but all these technologies improved the overall VMAF rating, the overall quality of experience of your viewers quite significantly. So I think, if you're not thinking about, I mean, you're here in the room, so you're thinking about it, but I think it's a technology that you should be very strongly considering in the short term. Your on-premise alternatives are either Capella Systems and CAP-CRF. In the cloud, Brightcove has it. I know Bitmovin has either announced it or will soon be announcing it. And then Fastech is here at the show with kind of a licensable option. I've got 32 seconds for questions. It's a joke. Go ahead.
I'll try to shout. Until I do that, it's 32 seconds.
Yeah, time's up.
Sorry, I'll shout very loud.
Okay.
Thanks, that's very interesting. My little question is, do you think Brightcove or some other players are showing better results because probably they use different encoders? I would have suggested probably you take the decision on the ladders at the bitrate and run the same encoding across the platform to see the advantage and discarding
I'm sorry,
the
you're gonna have to talk slower. I'm sorry.
Oh, I'm sorry. So I'm thinking, don't you think the improvement brought by Brightcove, for example, is not only based on the new ladder decision, but also they use a different encoding technology and different, more efficient video encoder?
They use the same encoder.
It was the same encoder for both. So they had to use the same, the only thing that varied between the two encodes was the per title yes or no. So we basically turned per title off to get to the baseline encodes. And that was one of the things we insisted upon because, and we did the same with all competitors. So if you encoded with the medium profile for your baseline, you couldn't encode with the very high profile for your per title.
So not knowing much about VMAF, does it take into account stream switching? Does it give you a negative impact when you do a stream switching, or does it not take into account when you come up with that score?
I'm sorry, I didn't follow. I don't hear very well.
Sorry,
It's
the VMAF scoring, does it take into account if the stream switches between bit rates back and forth?
No, it's stream to stream. So VMAF is stream to stream metric. Any other questions? Okay, thanks very much.
Thank you.